Hello everyone, and welcome to another video. In this video we're going to be looking at section 3.2 on the sine law. In our last video we looked at trig ratios and also using the Pythagorean theorem. So if you need to watch that, go back and watch that. What we're asking here first though, it says, which triangles below can the primary trig ratios or Pythagorean theorem be used on? So if you remember from the last video, there's only certain triangles that we can actually use these two things on. And trig ratios, those were our sine, cos, and tan ratio. So looking at these, if you want to pause the video and try to guess which ones, you can actually use sine, cos, and tan and Pythagorean theorem. The a squared plus b squared equals c squared. So if you guessed these ones over here for what we can use, you would be correct. So those ones we actually can use. These ones here on the right, we can't use those. Okay, and the reason that we can't use the ones on the right here is because none of these have a 90-degree marker like these ones do. These all have a 90-degree mark, so you can use sine, cos, and tan, and you can use the Pythagorean theorem. So I'm just going to write at the top here. So these are all right triangles, so we can use what we had done in the previous video. But these ones here, these are oblique, meaning there's no right angle. So we cannot use what we did before. Now, if we get a triangle where we don't know what the angles are, we don't want to use the primary trig ratios or Pythagorean theorem, because if there's not a 90-degree, they can't be used. So you always want to try to avoid using them. Okay, so it says if we're unsure of the angles, do not use the primary trig ratios. What we want to use instead is we want to use the sine law, and we're going to get into that now. So the actual sine law we'll get into down below here. To begin with though, it says, and if you guys are writing out the notes, don't write out this part. You can kind of look at it and think about the question, but don't write this part out. So it says, could you solve these triangles? And the word solve, whenever you're solving a triangle, if you remember, that meant to find all the missing angles and all the missing sides. Okay, so looking at the diagram, could you find all the missing angles in here, all the missing sides? So looking at the triangles, I don't see that there's any 90-degree marker or an angle stated to be 90, so I can't use the primary trig ratios and I can't use Pythagorean theorem. So the primary trig ratios and Pythagoras theorem can only be used to solve right triangles. These are not right triangles, meaning they don't have a 90-degree. An oblique triangle is a triangle that does not contain a 90-degree angle. Okay, so these would be oblique. So we're going to have to use something new. Okay, and that is where the sine law is going to come into play. So it says the sine law can be used to find unknown measurements in oblique triangles if you have two pairs of opposites with only one unknown variable. So I'm going to draw a little picture of what that means. So I'm going to draw a triangle over here. Doesn't have a 90-degree in it. And let's say we were given this side, let's just say hypothetically it's 15, and then we're told this is 30 degrees, and then we're also given this side, let's say that's 18, and we were asked to find this angle right there. So I'll just put a question mark. So in that triangle, I have kind of this matching pair. I have 15, and across from it is angle 30. So I'm going to circle those as a matching pair, and we're going to do this too when we actually go to solve questions. And then I have this question mark and the 18 as a matching pair that they're across from each other. Okay, so that's this two pairs of opposites. They're opposite across from each other, and there's only one unknown variable. So there's only one unknown thing, that's the question mark. You can only ever have one unknown thing. If there's two, say here and here, you can't use this. You're going to have to try to use some other method first. Okay, but that's kind of the general idea. So what this sine law states is this right here. It says side A over sine of A equals B over sine of B which equals side C over sine of C. Or if you took this whole thing and you just kind of flipped it, you would get this where all the sines are in the top and then all the sides are in the bottom. Okay, now the reason we got two different formulas here is because one of these is going to be easier to find different things. So this one right here on the left, that's going to be easier to find sides because this A, B, and C, they represent sides. They're already in the numerator, which is going to make it easier to solve. So those are used to find sides or lengths, that means the same thing, since it's already in the numerator. This side is already in the numerator. Now this one here, this is going to be used to find angles, because angles are already up in the numerator. So we have sine of some angle over the side A. Okay, all the angles are in the top, so those we're going to use to find angles. And again, for the same reason, because it's already in the numerator. So I'm going to quickly try to explain what this formula is actually doing. I'm just going to draw a quick little triangle here, and we're going to label it. We'll put A, B, and C. So across from A is going to be side A, across from B, side B, across from C, side C. Okay, so what this formula is saying is if I take A, so this is A, side A, and I divide by sine of the angle A, divide by sine of angle A, that is going to equal, say, B, side B, over sine of B. Or it could also equal C divided by sine of angle C. So that's all this is saying. It's basically saying they all have the exact same ratio, the exact same fraction, and we can use it to find missing sides or angles. So what we're going to do next is we're actually going to prove this law. Okay, so we're going to start out with our proof here. We're going to have a general triangle where we don't know any of the angles, we don't know any of the sides, and then we are going to come up with this proof. Now, I understand that proofs are difficult. I want you to just kind of watch it and see how it goes. You're not going to make total sense of it the first time you see it. Maybe a few things will make sense, but you can always just rewatch and hopefully it makes more sense the second time. So what I'm going to do first is I'm going to label all my sides, kind of like what I did on the previous page. So across from A is A, across from angle B is B, across from angle C is C. And then what I'm going to do is I'm going to cut this triangle in half, and I'm going to introduce a 90 degree here, because if I have 90 degrees, I know I can use Pythagorean theorem, and I know I can use my sine, cos, and tan ratios. Okay, now that length I'm going to call h. H just kind of stands for height. So what I'm going to do is I'm going to try to relate in this triangle what h is using the sine ratio, and then I'm going to do the exact same thing for this triangle. I'm going to use the sine ratio and try to see what h is, and then I'm going to take each of those things, what h is for this and what h is for this one, and I'm going to say that they are equal. Okay, might seem kind of confusing, might make more sense once we actually kind of do it. So looking from this left one here first, so I'm going to be looking from here, I'm going to put my little dude there. This is going to be the opposite side. This is my hypotenuse, and this is my adjacent. Okay, now I'm going to use the sine ratio. That's opposite over hypotenuse. And then I'm going to fill this in going from that angle A, so sine of A. So opposite is h, and then the hypotenuse is right there, that is b. So I got h over b. Okay, and then what I'm going to do is I'm going to multiply on both sides by b to get rid of this b. So b's cancel, and then I only have an h on that side. So I have h equals b sine a. So I know what h is for that side of that triangle. Then I'm going to do the same thing for this other triangle. Okay, so now I'm going to be standing in this corner, and now all the way to the middle there, that is opposite. And this is my hypotenuse, and this here is my adjacent. Again, I'm going to use sine ratio, so sine theta is opposite over hypotenuse, and we'll fill it in. So sine of the angle, we are going from B. Opposite is that H, and then the hypotenuse, we called that, it was A. Okay, now I want to get the H by itself, so we're going to multiply on both sides by A, and then the A's cancel, and then what I get is H equals A sine of B. So I can see from each of these, for this triangle, H is equal to B sine A, and for this other triangle, H is equal to A sine B. So what I'm going to do next is, because I know this is H and this is H, I can set these two things equal. It's kind of like this. Imagine if I was here and you were here and you knew that I had $5 and I knew that you had the same amount of money as me. So if you have the same amount of money as me, you must also have $5. Okay, so they both have to be the same. We're doing the same kind of thing with H. So I'm going to take these two and I'm going to set them equal. So B sine A is going to equal A sine B. And the property, or kind of the rule that allows us to do that, this is called the transitive property. Think of it as transit. They're kind of transiting, they're moving together, and we're setting them equal. Okay, so we almost have the sine law. Now we just got to do a couple little things to get the actual sine law. What I want to do is I want to get all the A's on this side and all of the B's on this side. So I want to get rid of the A on the right. To get rid of that A, I'll divide by A. I got to do the same on the left though. So those A's will cancel. I've gotten rid of the A. To get rid of the B on the left, I'm going to divide by a B, but then I also have to do that on the right. So B's will cancel there. And then what I'm left with, anything that didn't cancel, I got sine A over A equals sine B over B. And that is essentially the sine law. The only thing that's missing is the sine C over C. And the way we would get that is we would take our triangle and we would just cut it in a different shape so that we got maybe two triangles like this. And then we would get this other part, but I'm not going to go through kind of that part. We're just going to leave it at that. That is our sine law. And at the end, once you finish your proof, I was always taught, you put a little box, and that box represents the proof is complete. So now that we're done with the proof, we can move on to examples. And don't get frustrated if you find the proof to be difficult. I would go back and kind of rewatch this section and see if you can maybe do it on your own. Proofs are never easy. So on to our examples. The first one says in triangle ABC, and then C is 6 and A is 12 and angle A is 83 degrees. Determine the measure of angle C to the nearest degree. So what we should always do whenever you're given a question like this but no triangle, draw a triangle. And then we're going to label it ABC because that was the corners that they gave for us. And then I'm going to start to put on the given information. So side C is 6 units, so I'm just going to put 6 over here. A was 12 units, and angle A was 83 degrees. And we are going to be finding angle C, that was right here. Now what we want to do is you want to see if you have those matching opposite pairs. Like this one, we have 83 with 12, they're on opposite sides, and 6 we have with the question mark. So if you have that going on, you can use the sine law. So I want to find this angle C, so I'm going to put sine of C over, and then the one that was across from it, which was 6. So sine C over 6. And this has to equal, then I'm going to put sine of, and I'm going to use A, so it was 83, over the one across from it, which was 12. Okay, so there's our sine law set up, and now I just got to find what C is. So I got to isolate the C, get it by itself. So I'm going to multiply first on both sides by 6. So times by 6 times by 6. Our 6's cancel. So I have sine C equals 6 times sine 83. I just changed the order there. Divide by 12. And now the only thing to get rid of is this sine. So to get rid of sine, we have to take sine inverse. So sine inverse that side, sine inverse this side. So sine inverse cancel, and then the only thing we have coming down is C. So C equals, and then this whole mess, we're going to take that, put that all in our calculator. So let's go ahead and do that. Bring out our calculator, turn her on, and then we're going to type this. So start with inverse sine, so sine like that. Got to click second and then sine, and that'll bring up sine inverse. And then we're going to do 6 times sine of 83. Close that bracket. That's for this, just this one. And then we're going to go divide by 12. And then I have to close the bracket there. That is for this one, the big one. Okay, and then before we click enter, make sure you're in degree mode. So go into mode, go over, make sure it's on degree, and get out of there. Okay, and I can click enter. So I get 29.753. So we've gotten that, but our question said we need to round to the nearest degree. So this 7 is going to cause this 9 to round up, so 29 will round up to 30 degrees. And then just as a quick check, see if the angle you got makes sense. So for an angle of 83, a big angle, we got 12, that's pretty big. For an angle of 30, right, this is 30, across from that we got 6. So smaller angle gave us a smaller side. Bigger angle gives us a bigger side. So just do a quick check and see if the angle you got, it actually makes sense. So there's our answer for the first one. Moving on to the second one. So again, we're not given a triangle, so I'm going to start by drawing a triangle, and it's called PQR. So I'm going to label mine PQR. And it said angle P is 36, so we'll put 36 in there. Angle R is 47.9 degrees. And side Q, which is across from angle Q, is 21.3 centimeters. And then it said solve for side R to the nearest tenth. So we're finding this side right here, side R, across from angle R. So I have this matching pair, R and angle R, and I'm looking for another matching pair. I got either this option here, or I have this option here. Out of those two options, both of them are missing something. This one is missing an angle, and this one is missing a side. And remember, we can't have any missing things in our one pair. So I need to either find P or I need to find angle Q. Now one of those options is going to be easier than the other, and that is going to be finding this angle Q. Always try to find an angle instead of a side. It's going to be way easier. So I know that there's 180 degrees in a triangle, and then if I remove these two other angles, it'll just give me what's left in this angle. So 180 degrees minus 36 degrees and minus 47.9 degrees, that is going to give me 96.1 degrees. So now I have this matching side and angle with that other matching side. So I can use my sine law. So I'm going to set it up with R over sine of R, angle R, so that's 47.9 degrees. So in this one, what I'm doing is I'm putting the side in the top because I'm finding that, and it's always going to be easier if it's in the numerator. If we compared with the last one, I put the angle in the top because we were finding the angle. Okay, now we're finding a side, so put the side in the top instead of the angle in the top. And just so I don't confuse anyone, the angle always has to go with sine. Okay, you can't put a side in with sine. The angle is always with sine. So now that I got that one set up, I can use my other one. So that was this one that I drew. So it's 21.3. Remember, we're putting sides on top. 21.3 divided by sine of the angle across from it, which was 96.1 degrees. And then all I got to do is isolate this r, and I'll have what r equals. So I got to multiply on both sides by sine 47.9 to get rid of that. So multiply by that, 47.9 degrees. Do the same on the other side. Sine of 47.9 degrees. These two will cancel. And then r is the only thing coming down. So it's 21.3 times sine of 47.9, all being divided by sine of 96.1 degrees. Okay, and then we'll take that and put that into our calculator. So 21.3 times sine of 47.9, close the bracket around that sine, divided by sine of 96.1, and then close the bracket for that sine ratio. Okay, and then we click enter, and we got 15.894. Dot, dot, dot. There's more decimals after that. Just going to get this out of the way. And then rounding this off, we needed it to the nearest tenth. So that's going to give me 15 point, and the 9 is going to round up the 8. So we get 15.9 centimeters. Okay, on to our last one now. So this one is an application question. It's kind of describing a scenario. Again, not given a picture, so we're going to want to draw our picture. So it says Jeremy is currently at point C. He must walk 70 meters from A to B. He knows that A is directly north of C and B is 105 meters in a direction of north, 41 degrees east from C. What direction must Jeremy walk when going from A to B? Okay, so questions like this, there's a lot of information. Whenever you have something with directions, you're going to want to draw a grid, okay? And then just go through each piece of information piece by piece. So I'm going to draw my north, south, east, west here. So I got my grid, and then I'm going to go through my information. So it said Jeremy is currently at point C. Okay, he must walk 70 meters from A to B. So I don't really know where C, A, and B are yet. He knows that A is directly north of C. So that's a good sign. So let's write that. So A is directly north of C. So I'm going to put C right in the middle, and then I'm going to make A directly north of it. So I know where A and C are now. It said B is 105 meters in a direction of north, 41 degrees east from C. So starting at C, I'm going to have to go north and then go 41 degrees over towards the east. So something like that, and that is point B. Okay, and then the question asks, what direction must Jeremy walk when going from A to B? So there is our triangle. We just got to put in this measurement here. We were told that was 41 degrees, and that was 105 meters when we walked from there to there. And we also knew that from A to B was 70 meters. So from A to B, we can put on 70 meters there. So again, we want to try to apply our sine law. We got to look for matching opposite pairs like this 41 and this 70. So that'll be good. And then this 105 I can have going with that angle A there. Okay, so I am going to try to find that one missing thing in all of that, which was angle A. So I'm going to put sine of A, so I'm putting angle on the top now because I'm trying to find an angle. Sine of A over the one across from it was 105 meters equals, then I use my other matching pairs, so sine again has to go on the top because it went in the top here. So sine of the angle, 41 degrees, over the one that matched with it, which was 70 meters. Okay, and then I got to get that angle A by itself. So we're going to first multiply on both sides by 105 meters. Do that on both sides. Those are going to cancel out. So let's write out what we have. Sine A equals 105. Again, I'm just changing the order. 105 times sine of 41 degrees divided by 70. And then I just got to get rid of the sine. So to do that, take sine inverse. So we got sine inverse, both sides. Sine and sine inverse cancel. So the only thing coming down is that angle A. So I got A equals sine inverse of all of this stuff. 105 times sine of 41 degrees divided by 70. Okay, and I'm going to type that all into my calculator. So second sine, there's our first bracket, and then go 105 times sine of 41. Close the bracket. Again, that's just for this little one here. It's kind of like there's imaginary brackets right here. And then I got to go divide by 70 and then close that bracket. That is this big bracket here. So I got 79.76. So if we were to round that, we know that angle A is about 80 degrees. Okay, but the question it asked for, it said, was what direction must Jeremy walk when going from A to B? So if we are going from A to B, I'm just going to zoom in here. If we're going from A to B, I'm going to have to go south and then east. So I'm going to go south and then over, and that angle we got was 80. So it's going to be south and then 80 degrees over to get to B. So south, 80 degrees east. So let's write that. So there's our answer. Again, south and then 80 degrees towards the east. So now that we're finally done that one, I'm just going to write out our textbook questions here at the bottom.